Okay, let's look at correlations and regression in Minitab. So, for this video, we're going to consider in what situations you might want to use a correlation or regression analysis, and then see how you would do that in Minitab. So, the tests we've looked at so far are really, that includes t-tests, Mann-Whitney U-test, ANOVAs, Kruskal-Wallis, general linear models. Those are really all tests for differences. What you're looking for there is the difference between two means, for example, or the difference between two medians, or you're looking for the difference between three groups of data. Correlations and regressions are for tests of relationship. So here you're looking for whether or not one variable changes in response to another variable, or if change in one variable is linked to a change in another variable. So it's not test for differences at all, it's test for relationship, and that means we need two different variables that we're going to relate to each other. Whereas in tests for difference, like with the t-test, you have two groups of the same variable that you're comparing with each other. Here you have two different variables, right? Apples and oranges, that you can correlate or regress with each other. Okay, let's take an example. Let's say we have an example of the I don't know, world ranking in chess. So of all the countries in the world, how are they ranked, and then how much money they spend on chess clubs. Okay, silly example, but let's just do that. That's two different variables. One variable is what is the ranking in the chess league tables in the world, and the other variable is how much money do you spend on your chess clubs in your country. Okay, let's say, for example, there is a country that is ranked number 4 and it spends $2 million on chess clubs. And then there's another country that is number 16 in the world and it spends $1.5 million. Okay, and we can carry this on. We can have a country that's 125th in the world and that is spending, you know, $345,000. And let's keep going. Let's maybe make these numbers a bit more specific instead of just rounding them so broadly. Let's say this is actually 2,100,000 6 and 7. Let's do that. Okay, let's give these some nice specific numbers. 143390. Is that millions? No, that means a 1. There we go. That's millions. Yeah, 345,621, something like that. Okay, let's do that for a few more countries. Let's say number 23 in the world. Like that. Let's say number 78 in the world spends this much. Let's say they spend $678,921. And let's say one more country who is 112th in the world, and they spend. Okay, there we go. So we've got the world ranking as one variable, we've got the spend on chess clubs and another, and what we're interested in finding out is, does the amount of money you spend on your chess clubs actually influence the ranking in the world chess tables? So how can we do that? The first thing you want to think about is, like with any other data you're going to be using in Minitab for any other test, is are these data continuous? Because if they're not continuous, you can't use them for a correlation or regression. Continuous means you've measured them on some kind of scale. There's exclusions to this. There are regressions you can use on categorical data, but they're not part of this tutorial, and they go a bit beyond what we're going to be covering in the basics of statistics and Minitab. So for this purpose, for a basic correlation, your basic regression analysis, the data should be continuous. So the world ranking in chess, is that a continuous variable? Well, how many countries are there in the world? What, 200 or so? So that functions like a continuous variable. The ranking you have in the world could be any number between 1 and 200, and they're proportional on a scale. Like if you're the 4th best country, that is better than being the 12th country. So we can treat this as a continuous variable. How about the spend? Well, money we spend, we can measure on a continuous scale, on cents and dollars. So that, again, is a continuous variable. So we have two continuous variables. Fantastic. But what we don't know is whether these variables are normally distributed or not. Like with all the other tests we've seen so far, there are parametric and there are non-parametric correlation and regression analyses. Or I should say correlation analyses. So there is tests you can use if the data fit those assumptions of a parametric analysis, and those you can use if they don't. So in this case, we have to check both of these variables for normality to see if we can use a parametric correlation analysis. So let's first look at the world ranking of chess. Let's go to Stat, Basic Statistics, and then choose Normality Test, like we did before. The variable we want to check is column number 1, the world ranking in chess. Click OK. And what do we find? Here's our normal distribution, the red line. The blue dots scatter around that quite randomly, and our p-value is 0.0271. That is above the critical p-value of 0.05, so we accept the null hypothesis. There is no difference between these two things, the normal distribution and our data. Therefore, the data are normal. Okay, so those data are fine. What about the spend? Let's look at that. Basic statistics, normality test, and the spend on chess clubs. Let's click OK, and once again, the data seem to fit the red line fairly well. We get a p-value of 0.529, so that is again a value above 0.05, so we accept the null hypothesis. There is no difference between the normal distribution and our data. We can use these data for a parametric correlation analysis. Okay, so now we assured ourselves these data are continuous, they fit a normal distribution, we can carry on with our correlation analysis. Now, just out of principle, I will show you, or just for the purpose of this tutorial, I will show you what a non-parametric correlation would look like. Because it's a very simple test, very similar to the parametric correlation test. So let's assume, for example, let's imagine for a moment one of these variables were not normal. Could we then use a correlation test? And the answer is yes. Where do we find correlation tests? Well, we go into basic statistics, because they're a very basic test, and we go down here and you can see there's something called correlation. If we click on that, we can choose one of our two, or both of our two variables, the world ranking in chess and the spend. Those are the two ones we want to correlate with each other. Okay, so we double click on those, they go into the variables used for the analysis, and then you can see here there's a little box saying method, and at the moment it's saying Pearson correlation. That is the parametric correlation test, the one that assumes your data fit a normal distribution. If the data don't fit that assumption, you can use a Spearman's row correlation. So let's use that one first. Spearman's row. It says display p-values, that's fine. Don't have to tick this box. Just go with a Spearman's row for those two variables. Click OK, and off we go. Now, what you'll see here is, oh, interesting. The Spearman row for world ranking, chess, and spend, it says equals -1. And then it says p-value asterisk. So what this seems like to me is that there is a super strong negative correlation between these two variables. In fact, it's so strong that it doesn't even spit out a p-value. Okay? And the reason I know it's strong is because the R value, this is this here, the Spearman's row, also called R, for this correlation is -1, meaning when the value is close to 1, it means it's a very strong correlation, and the fact that it's negative means it's a strongly negative correlation. Does that make sense? Let's think about this. Yes, it makes sense, because the more you spend on your chess clubs, the lower your chess rankings. So as chess spending goes up, the rankings get smaller. You get higher up the rankings. Okay? Let's see what happens if we do the same kind of test, basic statistics, correlation, but use the Spearman's test instead. Let's do that. Pearson correlation. Click OK. And what happens here? Oh, this time it works. So the Pearson parametric test seems to be coping with those data a bit better, but the results are very similar to what we found with the Spearman's rho correlation. First of all, you'll find the p-value here is 0.016. Is that below our critical p-value of 0.05? Yes, it is. That means we reject the null hypothesis, which in the case of a correlation is there is no correlation between these two variables. So we reject that and we say, yes, there is a significant correlation between these two variables. What direction does that correlation have? It's negative. You can see that from the Pearson's R. Yeah, Pearson correlation, also called R, minus 0.894. So negative, meaning the more you spend, the lower your chess rankings. And when I say lower, I mean the smaller the value of it, so the higher up the ranking you go, if that makes sense. And the value of it is 0.894, which is close to 1, meaning it's a very strong correlation. Okay? So how much you spend seems to have a big effect on the rank you achieve. Now, those are the basic correlation tests we can do. And they tell you if there is a relationship between two variables, and they tell you what direction that has and how strong it is. But what it doesn't tell you is what exactly the nature of that relationship is. What change in spend results in what change in world ranking? Can we find some kind of way of calculating that? Well, that's what a regression analysis allows you to do. So what you want to do is, for a regression analysis, now a regression analysis you can only run on parametric data, on data that fit a normal distribution. So we've tested the data for normality already, so we know that we can use a regression on these data. So if I go into stat and go into regression, I can go here into the regression models, linear regression models, and it says fit linear or fit regression model with a little line through some dots. Click on that and it'll come up with this box and it'll ask me, what are the responses of your regression? What is the thing you think is responding? So what should go on the y-axis of your regression, if you see what I mean, right? The response is whatever's being influenced. Now, you're assuming there's a causal relationship here. You can't necessarily conclude that, but you could speculate. What is causing what? What is affecting what? And I think in this case, it's quite obvious that the assumption we would make is that the thing being affected is the ranking, because what we're spending is going to influence the ranking. So the response should be the world ranking in chess, and the predictor should be the spend. Okay? So in this case, we only have one predictor, but you can see you could have multiple predictors. That's more for more sophisticated regressions. For now, we'll just keep it as one continuous predictor, the spend. Okay, so we've got the world ranking of chess as a response, the spend as the predictor, which goes on the x-axis, and like with the ANOVA, we will want to check that our model actually worked. So we'll have to store the residuals of the regression model. So click on storage and tick residuals. So it'll store the residuals for you. Click OK. Now we've tested the data for normality going into the model, but we haven't checked, and what we need to do with the residuals is check that the model actually worked once we've run it. Okay, let's click OK. Boom, that's in the analysis for us, and here is the column with the residuals. Let's check those for normality first before we go any further. So stat, basic statistics, normality test, residuals, right? So these should fit a normal distribution if our model properly fit the data. So click OK, and as you can see, the points scatter quite randomly around the red normality line, and the p-value is 0.299 above the critical value of 0.05, so the data do fit a normal distribution. Okay, there's no difference between the data and a normal distribution. They fit a normal distribution. Fantastic. So the model worked. The residuals fit normal distribution, which is what we would expect if a regression model works. So in this case, we're happy with our regression model. Now let's look at the output from the regression model. What does it tell us? First of all, it says it has a p-value, and it has a p-value for the spend predictor. Okay? And that p-value is 0.016. Do you notice how that is the exact same p-value we had for our Pearson correlation? So the regression does a Pearson correlation for you, okay? And it gives you the same p-value. In this case, 0.016. So it says there's a significant relationship between the amount you spend on your chess clubs and your world ranking in the chess tables, okay? But what we can't see from this is what is the actual relationship. The regression analysis draws a trend line through the data. So you know how you fit a straight line through the data in a scatter plot? That's what the regression analysis does. And the equation for that is down here. It says regression equation. The world ranking in chess, so the value on the y-axis, y, equals 132.4 minus 0.000071 times the spend. That's the regression equation. Now what you'll notice here is that the value here, minus 0.000071, that's a gradient of the straight trend line. It's a negative value. Just like our value up here was negative, indicating a negative relationship, so is the slope of our trend line, a negative slope. Meaning the more you spend, the smaller the number that reflects your world ranking, so you're going up in the rankings. Okay? So with this equation, you could calculate any world ranking. You could predict your world ranking. If your government, if you're say you're a dictator of a country, and you say to your assistant, I want to be number 10 in the world, at least in world chess rankings, because I love chess so much. I want our country to be proud and represented in chess world league tables. I want us to reach ranking number 10. How much money do we have to spend in our chess clubs to make that happen? And based on this relationship, you could work out, you could calculate, you could rearrange the equation, you could insert 10 for the world ranking, and then rearrange the equation to work out the spend, how much spend you would need to get that result, to get that ranking. Okay? So that's what the regression equation allows you to do. Okay? Now, if you wanted to do this as a graph, as a visualization, and I'll do a separate video on graphs in a moment, a short video on graphs, because to be honest, Minitab is not an excellent tool for graphing. But if you wanted to visualize this, we can do that by creating a graph. We can create a scatter plot. We can do a whole bunch of graphs, right? So say for example we want to do a scatter plot. Let's do that. And it says here scatter plot, a simple one, a one with groups, or one with a regression. Let's do one with a regression. We've got one group of data, two variables with a regression line. Click OK, and it's asking you, what is the y variable? The y variable, remember, the response variable being affected is the world ranking in chess. The x variable is the spend, how much we're spending on. That's influencing the world ranking. You can add different labels, you can change something. So there's ways to play around with this, but that's the basic graph we want. Click OK, and there you go. It's producing a lovely scatter plot with a trend line going through the data. And the equation for this trend line, the equation that describes this trend line is exactly this equation over here in your session window. Okay, so for any given spend, you can work out what the expected world ranking is going to be. That's regression and correlation in Minitab. Very basic. You can you can make this much more complicated by adding in additional variables. So you could add in other variables like the educational system, how much do we spend on education, maybe that influences how well we do in chess and so forth. You can do more complex models, so you can do multiple regressions and so forth. But for the basic regression and the basic equations you get from it and so forth, this is what you would do, and this is how you would run it in Minitab. Okay, that's the regression tutorial. Like I said, I'll do a short video now on the graphing in Minitab, and that will wrap up the tutorials in Minitab.